We do it over 20,000 times a day, and most of the time, we don't give it a single thought. But have you ever stopped to wonder about the incredible journey a single breath actually takes? Well, today we're going to follow that journey from the air all around us to the very cells that power our existence.
But first, let's kick things off with a question you've probably felt but maybe never really thought about. Why is it that when we're alive, we're warm, but the moment breathing stops, the body goes cold? Well, the answer is hiding in plain sight, right inside the very definition of respiration.
And that question brings us right to the fundamental why of breathing. So in this first section, we're going to uncover how every single breath you take is directly linked to the energy that powers your body and the heat that keeps you alive.
The easiest way to think about respiration is like a slow, controlled fire happening inside every one of your cells. Your body takes in oxygen and uses it to burn food molecules. This releases the energy for everything you do, and, of course, the heat that keeps you at a steady 98.6 degrees. Now, the technical term for this is a catabolic process, but all you need to remember is that without that constant supply of oxygen, that internal fire simply can't burn.
Of course, we humans aren't the only ones who need to breathe. Across the entire animal kingdom, life has found some truly ingenious ways to pull oxygen from all sorts of environments. So let's take a quick look at some of these amazing adaptations. Now, what's really fascinating here is just the sheer variety of solutions to the exact same problem. Mammals like us, we use lungs. Insects, they have this whole network of tiny tubes called a trachea that delivers air directly to their tissues. Fish use gills to pull dissolved oxygen right out of the water. And then you have the ultimate adapter, the frog. It uses gills as a tadpole, lungs when it's on land, and can even breathe right through its skin while it's dormant. How cool is that? So all these different strategies, they're all achieving the exact same goal. Now, let's bring it back home to our own bodies and trace the precise path that air takes when you inhale, step by step, all the way to its final destination deep inside your lungs. Okay, it all starts in the nostrils, which act as a filter. From there, the air passes through the pharynx, that's a shared space for both food and air. Then it hits the larynx, your voice box. Next, it travels down the trachea, or what you probably call your windpipe, which then splits into two tubes called the bronchi, one for each lung. These bronchi branch out into smaller and smaller tubes, finally ending in millions of tiny air sacs called the alveoli. And this is where the real magic happens.
But wait, how does that air get pulled in and pushed out in the first place? Well, let me introduce you to the unsung hero of respiration, the diaphragm. It's this large, dome-shaped muscle right below your lungs. When you inhale, it contracts and flattens out, creating a vacuum that just sucks the air in. And when you exhale, it relaxes, pushing up and forcing the air out. It's doing about 70% of the heavy lifting, all without you ever thinking about it.
So what's actually changing with each breath? Well, just look at these numbers. We breathe in air that's mostly nitrogen, right? But our body can't really use it. So the amount we breathe out is exactly the same. The real story here is the trade-off. We take in about 21% oxygen, but we only breathe out 17%. And that missing part, it was swapped for the 4% carbon dioxide that we exhale as waste.
And that exchange, that's the whole mission of breathing. That 4% difference is everything. It's the oxygen your body just harvested to fuel itself, and it's the carbon dioxide waste it's efficiently getting rid of. Just a simple, elegant, and totally life-sustaining trade.
But how in the world does that oxygen get from those tiny air sacs in your lungs all the way to, say, the muscles in your big toe? For that, we need to introduce the absolute star of the show, a special protein called hemoglobin.
Think of hemoglobin as the world's most efficient delivery service. It lives inside your red blood cells, just waiting around in the lungs. The second oxygen arrives in those alveoli, hemoglobin snatches it and holds on tight. It then travels through your entire bloodstream, dropping off oxygen at every single cell that needs it. And on the return trip, it does the cleanup, picking up all the cellular trash, the carbon dioxide, and carrying it all the way back to the lungs to be sent away.
Now, this system is remarkably reliable. It's incredible. But, like any complex machine, it has its little quirks and vulnerabilities. So let's look at a few common interruptions, and one that's particularly dangerous. Let's start with one we've all experienced. That annoying involuntary spasm. The hiccup. What is actually going on there? Okay, so picture a little flap in your throat called the epiglottis. Think of it as a traffic cop. Its job is to make sure food goes down your food pipe and air goes down your windpipe. But if you eat too fast or get distracted, that little traffic cop can get confused. A bit of food or drink might start heading down the wrong pipe, and that triggers a sudden, sharp spasm of your diaphragm to protect your lungs. And the hic sound itself? That's just the noise of your vocal cords snapping shut as the air is violently forced out.
All right, now for something far more serious. The source material puts the danger perfectly with this chillingly simple statement. This simple preference is exactly what makes an invisible gas so deadly. So here's the fatal attraction. If you inhale carbon monoxide, your hemoglobin will grab onto it over 200 times more readily than it grabs onto oxygen. It essentially kicks the life-giving oxygen right out of the car and gives the seat to this toxic imposter. The hemoglobin then circulates this poison all over your body, and your cells, they begin to suffocate.
On a different note, our breathing isn't always constant. The rate changes depending on our age and what we're doing. As you can see, a typical awake adult breathes about 16 times a minute. When you fall asleep, that naturally slows down to around 12. And a child with their faster metabolism breathes much quicker at about 25 times per minute. And finally, let's just talk about sheer capacity for a second. Your lungs can hold an astonishing 6 liters of air. That's as much as 3 of those big soda bottles. And yet for a normal, relaxed breath, what scientists call our tidal volume, we only use about half a liter. It just goes to show you the incredible reserve power our respiratory system holds.
So, from keeping us warm to powering our cells to fighting off intruders, this system is just a masterpiece of biological engineering. As we leave this explainer, just think about this. Your body performs this incredibly complex journey perfectly, over 20,000 times a day, all without you having to give it a single conscious thought. Isn't that amazing?